Hello viewers, so we have this question under chemical kinetics. It's saying the following data was measured for a reaction. We are given the reaction and then we are given a table that shows different experiments. We have experiment number 1 up to experiment number 5 using the concentration of the reactants and then also recording the initial rates. So this falls under chemical kinetics initial rates. So the first question is saying, what is the rate law for the reaction? Then we have what is the overall order of reaction? And the last one is saying, calculate the rate constant with proper units. So let's go ahead and see how we can find our answers. Let's start with the first one. What is the rate law for the reaction? Now, in order for us to determine the rate law for a reaction, we need to understand this concept. For example, if we have a chemical reaction where A is changing into B like that, the rate law for this chemical reaction is going to be, now what we should understand is we are only considering the reactants, not the products in this case. So the rate law for this type of chemical reaction will be equal to, we'll say the rate is equal to the rate constant K multiplied by the concentration of the reactant that we have here to a certain power. We can call that power X for now. Where this power we have here is the order of reaction according to that specific reactant. In this case, we're talking about A, reactant A. So this X represents the order of the chemical reaction according to reactant A. So if it's first order, it means the rate is going to be equal to, we'll say rate is equal to K to the power of, multiplied by the concentration of A to the power of 1. Now, when the power is 1, we basically don't show it. So it will be just in that format where we are saying the rate is equal to K multiplied by the concentration of A. If it's to the second power, we'll say this is going to be given to the power of 2. So it implies to say that's the order of reaction according to reactant A. So it's second order according to reactant A. Again, if it's zero order, it implies to say here we're going to have a 0. So to the power of 0 there. What this implies is, according to reactant A, the chemical reaction is 0 order, like that. In the same way, if we have a chemical reaction again, that is in this format where we are saying A added to B gives us maybe C and D on the other side. The rate law is going to be in this format. Rate is equal to the rate constant K multiplied by the concentration of A still to a certain order, let's call that X, multiplied by the concentration of B also to a certain order, let's call that order Y. As you can see again, we're not considering the product side. We are only focusing on the reactants. This is where the rate law comes from. We're talking about reactants that are there in that chemical reaction. Again, these orders or these powers we have is X and Y. These are orders of reaction according to that specific reactant. In this case, the order of reaction according to reactant A is X, and the order of reaction according to reactant B is Y. Yes. So these are orders of reaction according to each specific reactant. Now, these values of X and Y are what we need to determine for us to know fully the order of reaction that we have. Now, the overall order of reaction comes from the addition of those powers you have, the orders of reaction according to each specific reactant. You add them and then you find your overall order of reaction. For example, if in this case where we have X and Y, let's say we find X to be equal to 1 and then we find Y to be equal to 2. So this implies to say the order of reaction according to reactant A is first order and the order of reaction according to reactant B is second order. Then the overall order of reaction in this case is the sum of the individual orders, where we are saying we have 1 added to 2, meaning the order of reaction, the overall order of reaction was going to be third order in this case. Yes. So let's go ahead and see how we can determine the order of reaction according to the information we are given. So the information we are given here is we have BF3 added to NH3. As I said earlier on, we only focus on the reactant side. So if we are writing the rate law, they are saying what is the rate law for the reaction. If we are writing the rate law for this chemical reaction here, our consideration is the reactants. So in this case, we'll say, according to what we have there, we'll say the rate is equal to K multiplied by the concentration of the reactant. Now we can see the reactants we have here, we have BF3 and NH3. So we'll say K multiplied by the concentration of BF3, like that. To a certain power, we can call that one X, and then multiplied by the concentration of NH3, also given to a certain power that we don't know for now, we can call it Y. So the general order or the general law, the general rate law for that chemical reaction is basically this one that we have here. Our job is now to determine the value of X and also determine the value of Y. So now, how do we determine the value of X and how do we determine the value of Y? That's the question. All right. So to find the value of X, which is the power to BF3, we need to look at NH3, the concentration of NH3, where that concentration of NH3 is not changing, is constant. So we look for two experiments where the concentration of NH3 is not changing, meaning it's constant, and that will help us find the value of X for the BF3, or the order of reaction according to reactant, which is BF3. So to find for this one, we're going to check on the other reactant. We check where its concentration is constant, is not changing, and then that will help us find for this one, which is BF3. Again, to find for NH3, we are going to come back to BF3 and check on the experiments where the concentration is not changing, is constant, and that will basically help us find the order of NH3. You just find two experiments where the concentration of the other is not changing, and that's what we are going to use. So let's look at NH3 and see where the concentration is constant. We are just picking two experiments where the concentration is constant. So we can see, starting from experiment 3 up to experiment number 5, the concentration of NH3 here is constant. It means we can choose two of the three, and that's what we are going to use. Now, in this case, I'll choose 4 and 5. So I'll use experiment number 4 and experiment number 5. Now, what you do is, after choosing those experiments you are going to use the information you have everywhere. For example, you are starting with the information you have on BF3. On both experiment number 4 and number 5, you also go to NH3, you pick the information you have on experiment number 4 and 5. You also go on your initial rates, and then you pick what you have on experiment number 4 and number 5. And that's what will help you determine the order according to BF3. So let's go ahead and do that. Now, this is what we are going to do. So we have our rate law like this. Let's say this is for experiment number 4, and then this is going to be divided by. So let's do this. We'll say we have that, and then we are saying this is experiment number 4. So we'll say that's the rate 4, and also the concentrations are 4. Concentration on experiment number 4. We'll do that. Then this will be divided by the rate at experiment number 5, which is equal to, again, still K. We are still coming up with the same rate law, which is BF3 This is 2 to the power of x, and this is on experiment number 5. Then this will multiply by NH3 in that case. But on experiment number 5, still given to the power of y, since we are talking about the same reactant. So that's our equation that we are going to use. Rate 4 over rate 5, and we replace everything we have. So let's go ahead and do that. So now we go on rate number 4, we replace everything. When we mean replace everything, it means whatever you have on rate number 4 here, you replace. This is rate number 4. This is the concentration of ammonia on number 4. This is the concentration of BF3 on number 4. So you are picking everything on number 4. You put where you have number 4, and you are also doing the same on number 5. You pick everything you have there on number 5. So let's go ahead and do that. Picking what I have here, rate on number 4 is 0.1193, like that. Then this is going to divide by rate on number 5. What we have is 0.0596, like that. And this will be equal to, here we still have K, and then this is still dividing by K. We're going to say that this is dividing by K. And then the BF3 concentration on number 4, what we have is 0.350. So we have that, and this is given to the power of x. Down here we have 0.175. And this is also given to the power of x. Then on the other side, we have 0.100 for ammonia, and this is going to be given to the power of y, and we still have the same, which is 0.100, and this is still given to the power of y. So it implies to say we have now replaced everything wanted to replace. When you look at what we have here, you see that this that we have on top is the same as what we have down here. These two are going to cancel, and then also we have K here and we have K there. These two are also going to cancel. So let's quickly do that. What we are going to have is this and that will go, and also this and that will go. It implies to say all we have to do now is divide here, find an answer, and also divide here, find an answer. So what we have is like this. Let's rewrite it. We have something like 0.1193 divided by 0.0596 is equal to, we have 0.350 divided by 0.175. And this whole thing is given to the power of x. Remember, we have the same power here. This is the power of x, this is the power of x. So this is the same as that divided by this to the same power, which is power of x. So this is what we have. Now let's continue. So when you do mathematics here, 0.1193 divided by 0.0596, this is giving me a 2. So we have 2, and this is equal to, on the other side, I'm also getting a 2, and this 2 now is given to the power of x. So looking at what we have, when you apply the laws of indices here, we are going to say this is to the power of 1. So the 2 and 2 will cancel, and then our x is just equal to 1. But if you don't understand indices, you can still do your x is equal to, you say your x, this x here is equal to the log of the number that is not holding the variable here. In this case is 2, so we'll say log of 2 divided by the log of the value that is holding the variable. So divided by log of 2 again, and this will still give us 1. Now, you're not able to understand where to place the log on top and the log down because the values are the same. But what I'm saying is, you say log, you see here we have, let's remove that one. Here you have a 2 holding the variable x, and here you have a 2 that is not holding any variable. So you say log of the number that is not holding the variable you're looking for. For example, here is x. So log of this other number that is not holding the variable, and then divided by log of that number holding the variable. So that's what we did here. Log 2, the 2 is here on top, and then divided by log 2, the 2 that is holding the variable here. It's 2 giving us 1. So this implies to say, according to reactant BF3, the order of reaction is first order, which is 1. So here, where we have x here, the value of x is 1. Yeah, so we have determined the value of x. We need to determine also the value of y. So allow me to remove this part. All right. So I won't change here. I'll just remove the number of experiment we're using. So it's 4 and 5. I'll remove the 4 and 5 in this case so that we can reuse what we have again. So to find for NH3 again, remember what we're finding was for BF3, the value of x. Here we're finding the value of y, and we're finding the value that is connected to NH3. The order of reaction according to reactant NH3 in this case. So to find that, we're going to use the same method, but now we are looking at this BF3 that we have here. We are checking experiments where the concentration is not changing. So let's do that. And when we check here, we can see on experiment number 1 and number 2, that's where we have the same concentration. The concentration is not changing, it's constant. So it means we're going to use experiment number 1 and number 2. Yes, we pick everything we have on experiment number 1 up to there, and also on experiment number 2 up to there. When you do that, we are saying here now we are replacing to say we are using experiment number 1 and the experiment number 2. So we'll say this is 1, this is 1, and this is 2, this is 2. All we have to do is replace. Now rate on experiment number 1 is 0.213. So 2130 like that. Then this is going to divide by, we have a 0.1065. That's what we have. And then this is equal to, still we are having a k there. That is going to divide by another k here. The concentration of BF3 is 0.250. On experiment number 1, this will be given to the power of x, and it's still the same here, 0.250, because it's constant, it's not changing, the power of x, and this is multiplying by, we have 0.250 to the power of y, and we have 0.125 to the power of y again for ammonia. Yes. So again, as usual, you can see this here that we have, you can see this part and this part are the same. Also K and K are the same. So those are going to cancel. This will go with that. This will go with this. This implies to say we're going to have the same thing. We're going to divide this and then also divide that. This is the same as 0.250 divided by 0.125 to the power of y. Let's just rewrite that here. We'll say now we have 0.2130, that is dividing by 0.1065 like that, and this is equal to, on the other side we're going to have 0.250 divided by 0.125, and this whole thing is given to the power of y. All right. So when we divide here, 0.2130 divided by 0.1065, I'm still getting a 2, and then on the other side, I'm also getting a 2, and this is to the power of y. Using the same method we used earlier on, our y will be equal to log of 2 divided by log 2. Then this is still giving us a 1. It means also the order of reactant according to ammonia here is first order. Yes. So that's what we have now. Now that we have our order of reaction, it means we can go ahead and complete our rate law. So let's do that. What that means is this whole part here is going to go like that. Then let's remove also that part. Or rather, let me just remove everything. So now our rate law will be equal to, say, rate is equal to K multiplied by the concentration of BF3, like that, given to the power of 1, we found 1 there, multiplied by the concentration of NH3, also given to the power of 1. But when the power is 1, we don't need to write it like that, so we can just leave it like this, and this will be our rate law for that chemical reaction. So rate is equal to K multiplied by the concentration of BF3, that is multiplying by the concentration of NH3. And this is what we're looking for. So the key here was to find the value of X and Y. After finding it, then it implies to say we are done with our work. All we have to do is come back and write our complete rate law. All right. So the next one is saying, what is the overall order of reaction? So as earlier said, the overall order of reaction is the sum of the individual orders of reactants. So we found that our X was equal to 1 and our Y is equal to 1, meaning our overall order now will just be 1 added to 1, which is equal to 2. So the overall order of reaction is second order. The order of reaction according to reactant BF3 is first order. The order of reaction according to reactant NH3 is first order. But the overall order of reaction is second order. You shouldn't confuse those two. When they say the order of reaction according to reactant BF3, it means they are just talking about that specific reactant. According to reactant NH3, it means they are talking about that specific order according to that reactant. But when they say the overall order, it means it's the sum of the individual orders of reactants. Yes. So this case is saying the overall order, it implies to say is second order, the sum of the individual orders. The last part is saying calculate the rate constant with proper units. All right, so we need to calculate the rate constant with proper units. To do that, all you have to do is very simple. All you have to do is choose an experiment here. Choose an experiment here and then just replace with everything and calculate the value of K. Yes, the rate constant is K, and that's what we are looking for. And then we need to put the proper units for that. So you choose an experiment. You can choose experiment number 1, choose experiment number 2, choose 3, choose 4 or 5. Just make sure you're choosing a single experiment and it will give you the same answer. Whichever experiment you choose, you are going to get the same answer. So let's choose experiment number 1 and use it. How do we use it? We are looking for the value of K. So if we are choosing experiment number 1, it means we're going to replace with what we have for BF3 in experiment number 1, for NH3 in experiment number 1, and also the rate in experiment number 1. So when we do that, let's say what we are going to have is we're using experiment number 1. In this case here, making K the subject of the formula, you find that your K, you can make it the subject or rather just replace, still the same. So we'll say our K will be equal to the rate. Now we're talking about the rate 1 divided by the concentration of BF3 in experiment number 1 multiplied by the concentration of NH3 still in experiment number 1. Replacing here, you find that the rate on experiment number 1 is 0.2130, and this is going to be divided by the concentration of BF3 on 1 is 0.250 multiplied by, also we have 0.250. Now, the orders must be put there. Now, this is 1. When it's 1, you don't need to put it. But let's say if this was second order and this was maybe second order as well, or 0 order, it implies to say those orders play a very big role. You need to put them where they are supposed to be. Here, you need to put them. This is first order and that's first order. So the orders you have there need to show here because that's what you need to use there. In this case, we have first order and first order. We don't need to show them in this case, but I've shown them anyway. So yeah, let's continue with our mathematics. When we do our calculation here, according to my calculator here, I'm getting the value of K to be equal to 3.408. Yes, so this is the value of K. Now, they are telling us to say we need to put proper units for this value of K. So how do we determine the units in this case? So you use the overall order of reaction that you calculated. In this case, we said it's second order. So the formula you need here in this case is M. In any case where you're finding the units, this is the formula you need. M to the power of 1 minus n, then multiplied by s to the power of minus 1, like that. Where this n you are seeing here, the n you are seeing here is the order of reaction that you're talking about. So in this case, our order of reaction is 2. So we'll say it's m1 minus 2, and then s minus 1. This is giving us 1 minus 2 is minus 1. So we'll say m to minus 1, then s to minus 1. It means those are the units we are going to put here. Minus 1, then s to minus 1. It implies to say we have found our final answer like that with proper units.